In this video, we will calculate slope, and we will also learn about parallel lines. It's very important to have a strong conceptual understanding of what slope really is. Okay, so let's go over some concepts. Slope can be thought of conceptually as rise over run. Now what that means is, if you were looking at a line or a line segment, you would ask yourself, if you started at a point on that line segment, or here's a line, let's say. If we started out here, and then we walked to here, we would ask ourselves, how many did we rise, or go up or down? So how many numbers did we go up vertically, or down vertically in this case, up? And how many did we run? How many numbers did we go horizontally, either to the left or the right? This ratio, this fraction, this number represents slope. Okay? And so this is going to serve as a review, but we're also going to look into this concept deeper, just like we have in really all of our videos. You may or may not have been exposed to these things before, but now they're going to be way more deep. So, using this rise over run idea, here, I'm going to use M for slope. We'll talk more about that in a moment. Here is a flat line. This is like the bunny slope. So if you have a horizontal line that is flat, it has a zero slope. Why? Well, it's not sloping upwards, it's not sloping downwards, it's flat. So it's a good idea to have a concept of zero as flat, and then we could also have a good concept for what a positive slope is. I'm going to write m greater than 0, so that's positive slope. From left to right, how we read English, we're going up. That is known as positive slope. So if you calculate a slope that's positive, that means from left to right, you're rising, you're going up as you read English. Similarly, negative slope, from left to right, you are going down or decreasing. This is known as increasing or going up. Here we are decreasing or going down from left to right. So it's important to understand conceptually how slope looks. And when you calculate a slope, if you put it on a grid, you should just double check yourself. If you get an answer of 2/5 as a slope and your graph goes up from left to right, it increases, then you're probably on a good path. Now we'll be a little bit more formal here. In calculating slope, you need 2 points. So let's kind of draw a similar picture to last time, but it will be a little bit better. Let's say we have this line segment. A and B are points on this line segment. A has coordinates x1, y1, and B has coordinates x2, y2. If we want to calculate the slope, which we use an M for, you might wonder, where did this letter M come from? I think back in the day, like Descartes, who developed the Cartesian coordinate system, I think that they use M for slope, standing for monter en français, which means climbing or going to go up. So if we want to calculate this slope, we'll say how much we go up. What we'll do is we'll count how much we rise, and we'll count how much we run. But again, we don't want to be as conceptual as last time. We want to be a little bit more concrete. If you think of these points, on a coordinate plane, like let's say here's our coordinate plane, here's the x-axis, here's the y-axis. If we want to know how much we went up or rose, we would look at the y values and see how much they changed. This is like a height, and this is another height because the y-axis measures height. And we would see how much they changed. We would look at the difference of heights. So imagine if we were at a height of 10, and this were a height of 3, we would do 10 minus 3 makes 7. That's the change in height, or the change in how much we rose. And then if we wanted to know how much we ran, how much we changed in a horizontal sense, we would look at the x-coordinates because the x-axis runs horizontally from left to right. And then we would look at those changes as well. We would look at the difference of where we ended up to where we began. And there we have the slope formula. This is one of the most important formulas that you must know forever. Now make sure that you have y on top. Another way to write this, if you want to get a little lazy, it's the change in y over the change in x. Okay, that is a delta, stands for change. It's like a kind of cool. Now that we know the slope formula, we really have to commit that to memory. So if we have a problem that asks us to find the slope between a couple of points, we should really circle or underline that key word, and then right away write down the slope formula. Similarly, almost simultaneously, right when you write down the formula, and notice how it's an equation. There's an equal sign, there's two parts to this equation. Make sure you always have two parts to your equation. Similarly, when you do that, you should also label this coordinate as x1, y1, and this coordinate is x2, y2. I recommend you do that immediately. It will really, really help you get set up. And notice how x comes before y, and they both get a 1, because this is your first point, and x comes before y, and they both get a 2, because this is your second point. Now that we've set ourselves up, we have the formula, and we have everything labeled, so now it's just careful record keeping. y2, oh, I might even do this too, just to set myself up. I might write the division symbol and the two subtraction symbols. Now I'm just going to plug in. I'm going to ask myself, what is y2? It's -7. What is y1? It's -1. What is x2? 4. What is x1? -2. Notice how I've been very careful to include the minus signs that are built into the formula, because remember, we're looking at that change in x and change in y. Now, if you subtract a negative, that turns into a positive. And that happens on both the numerator and the denominator. That's going to happen frequently, and have the confidence to do that correctly. So -7 plus 1, that makes -6. 4 plus 2, that makes 6. So that means like we're kind of rising -6, which kind of means like go down 6. And then since this is negative, that's for the down, this 6 means we're going to go right 6. That's kind of conceptually what we're calculating here. But then we can even clean it up a bit. We could call this slope -1. Now it is important to note that a slope of -1 can also be written as -1 divided by 1. So think of that slope as going down 1, right 1. Conceptually, since the slope is negative, it should decrease. It's going down the same amount as we're going to the right. Now keep in mind, that slope is really just -1, but it's good to have this concept to realize what it fully actually really means. And I know this isn't on an axis, but it's roughly going to be making a 45-degree angle, let's say, with the axis. And we'll learn more about that later. Okay, so we've calculated the slope. The only other thing I'd like to do is I'd like to write a little AB here, because everywhere on this problem we were finding the slope of AB. So not just M, but M sub AB. We found that the slope of AB is -1. And then circle your answer because we're done. And it always helps to kind of draw, sketch a little picture, because geometry is really all about pictures. So we've already alluded to this somewhat, so we'll look at horizontal lines first. If you think about it, if slope is rise over run, Horizontal lines, they never rise. So if we were calculating the slope of this line, we would get something like 0 divided by 5. If I had $0 divided by 5 students, they would each get $0. So what does that tell us? That tells us that horizontal lines have a slope of 0. Why? Because they're flat. I can actually think of my grandfather cross-country skiing. That's flat. That's hard work. You're not going downhill at all, and you're not going uphill at all. This is flat, so the slope is 0. So similarly, if you were calculating some sort of a slope and you got something like 2 divided by 0 when you calculated the slope, that would tell you that you actually have a vertical line. Why would that make sense? Well, that means the run, or the left to right, the slope of this line, that means that this line is not going left or right any. So it would have to just be going up or down, okay? It's not going to curve left to right or right to left at all. Slant, excuse me. It's not going to slant left to right or right to left at all. It's just perfectly vertical. There's no running. There's only rising. It's kind of like an elevator going up. So if you were to ever calculate a slope where you divided by 0, you would just say that slope is undefined. Honestly, the slope is really infinite, but that's kind of weird. It's very steep. Let's think of it that way. And we'd like you to say whenever you divide by 0, because you really can't do that, we'll say that the slope is undefined. Vertical lines have undefined slope, and I really want this to make good sense. Horizontal lines are flat, so they have a 0 slope. Now here I'm going to find the slope of a couple of segments. And remember, the first thing I'm going to do is I'm going to kind of crash the problem with some helpful information. x1, y1, x2, y2. That will give me access, as well as, if you read the problem carefully, we're finding the slope. So write the formula down first. Set yourself up for success. Okay, now I might do that, and I might even say, okay, now I'm going to find the slope of AB. So I've got my formula down. I'll never forget it. I'll set myself up with my division and subtraction symbols. Now y2, 5, minus y1, 5, over x2, 6, minus x1, 2. That'll be 0 divided by 4. If I have $0 divided by 4 people, each of them is going to get 0. And if you were to just kind of sketch this, we had the point 2, 1, 2, 3, 4, 5. We had the point 2, 5. And we had the point 6, 5, which is somewhere whoosh, 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 over here. This is a horizontal line segment. So our slope is 0. Here's our final answer. The slope is 0. Why? Because this is a flat line. It really, really helps to plot the points to give yourself a sense of what you're looking at and what this calculation really means. Similarly, if we wanted to find the slope of, I'm just going to crash these really quick. That almost looks like a 2, but we're going to pretend it's a 1. Okay, we can find the slope here, y2 minus y1 over x2 minus x1. That'll be 4 divided by 0. That, ladies and gentlemen, is undefined. If we were to sketch this, we've got 5, 2, and 5, 6. That's segment C, D. That's a vertical line. So we know that that has undefined slope because it's infinitely steep. That's not, on the bunny slope. That's not a flat land. That's not a slope of 0. That's like a, crazy skiing off a cliff or something. That we would not be skiing on a slope. So that slope is undefined, and we also know we can't divide by 0. Okay, very good. Now this is a very profound statement. Parallel lines have the same slope. So think about the yellow lines on the road. They never intersect. So they are known as parallel. Now, why does it make sense that parallel lines have the same slope? Why should we pair those together in our mind? Well, if you think about it, let's say this line, rises 6, goes right 7. And this line, let's say I pick a point on here. That same thing is going to happen. These two lines will never intersect. Why? Because they have the same rise and the same run, so they'll never touch each other. It's like this line is mimicking the slope of this line, so they'll never get to intersect each other because they're always doing the same amount of rise and run. The ratio is the same, so these two lines are parallel. So in the future, we're going to read some interesting problems, and they might say that, write the equation of a line parallel to, let's say, this line right here. Let's say I had, you guys remember y equals mx plus b? Let's say I had y equals 3x plus 5, and I wanted a line parallel to that. Well, real quickly, the slope here, that number attached to x is 3. We could make up any other line that has the same slope. So if you see that keyword parallel dealing with slope, you're going to use the same slope. That's a very, very fundamental idea. And when things get a little bit more complicated later, you need to have this knee-jerk reaction. If you see parallel, just write the word same slope. Just clue yourself in that way. And here's some quick practice for you. Make sure that you write the problems down. Do your best work, show out all work, and best of luck on all of them, especially number 4. It's kind of interesting. Remember, use your formulas and be very, very careful and deliberate.